Hello and welcome. The purpose of this video is to explain how to model in the software ideas modeler for the tool SQLINQ. So what SQLINQ is, it's a SQLite architecture for Unity 3D using LINQ and enterprise design patterns. This little part here is just a quick introduction. If you need assistance, you can go to games.lnsq.info where you'll find help and support. So that's the most important, well, not most important, one of the places to go. There's a link to support, and then of course there's a section on the actual LINQ environment, SQLINQ environment. The videos, this video is how to model with SIM and how models get transformed into code. There's a separate video, almost an hour long, that discusses discusses the architecture of SQLINQ, and other videos may be defined. It's important also to remember that if you open up the YouTube description below, you will find links to various parts of the video. So if you want to skip forward, you just click on the link and you'll be able to go forward. The purpose of this presentation, it's pretty much a deep dive into the software ideas modeler. I'm going to start a model from scratch, show you how the code is created, show you the interfaces into the software ideas modeler, and basically I'll explain how I'm using it. So you're going to see SQLINQ running in Unity 3D. I'll pop open the Unity 3D editor. I'm going to be using Notepad++ to show you the code, and I'm going to use the software ideas modeler. You'll see how I model things. And I have a very basic idea as to how it's going to work, and show you some of the basic, show you all of the features inside the tool. So getting the tool, you basically go out to the website softwareideas.net and download the tool. So that'll be in the description as well. All right. So if we bring up a browser, here's the software ideas modeler, and you just simply go here and download the latest version. Oh, look at that. It's been updated in March. Cool. All right. So I'm not going to update it with the latest and greatest. I'm just going to use the tool that I'm used to. The other website that is of interest is games.lnsq.info. And to get into the SQLINQ area, you just go into Unity 3D, and then under SQLINQ and link support. And then you can find out about my games here and stuff like that. So that's sort of the administrative startup part of this process. So we're going to be using Notepad++ in order to view the code, and I'm going to be generating into these three libraries. So in the top left-hand corner here, you see data domain, tables, and Unity, and they're currently all empty because there's nothing to show you. And then in Unity, basically, in order to set up your environment, you add a SQLINQ generator script. So I'm just going to go through the process here. So you go into add component and SQLINQ, oops, and then you just add a script accordingly. When you do, that script pops open and you have this sort of area you work in. You specify the name of the SIM file, which is the project file. So you don't need to export anything or anything like that. You just basically save your model, and this is the name of the model, and it's stored as an XML document, and I parse that and generate the code from it. You really need to go through, if you haven't already, you really need to go through this other video that describes the SQLINQ architecture, because I'm going to brush over a lot of what's going on in the background and just dive into how to model with the tool. So basically with the generator, you specify your namespaces, you specify where the code's going to be generated, you specify the physical location of the templates inside of Unity, and you can then generate your code. So you generate your code, and if this is part of your game, which in this case it's not because I have other active pieces, then it will generate straight into your game. You can also debug the SQL generator, see how it works. So to do that, you turn on script debugging, and when you click play in Unity, it'll actually start the generator. So it's sort of like calling the generate code button, but it will allow you to generate or see how it's actually executing by turning this script debugging on. So normally you don't need to do that. If you click play and this is turned off, nothing happens with this script. So this is all an editor extension, basically. So the SQLINQ environment, this is what you get in the environment. So you get an editor piece, which is essentially a script that controls this part of the modeler. You get a generator, which has all this cool and funky code in it. And if you had gone through the video, you'll know that the SQL UML model parser can be exchanged for something else. So you just basically replace this class with your own class, and you can then transform any other model that you have. This is the main generator, and the generator spec consists of generator spec, attribute, connection, and object. And then I have a few extension classes just to make my life a little bit easier. This is the SQLite.net library. You can get this on SourceForge. It's basically a link interface to a SQLite database. It's quite powerful. And so I didn't write that. I'm just embedding it into the application. What you're really paying for are these patterns and the ability to generate code. Once you see what kind of code it's generating, you'll realize it's, or I'm hoping that you realize it's a pretty powerful tool. And the last piece here is the templates. So when I actually generate code, and I'll just expand some of this stuff here. Oops. When I generate code, I'm basically gathering up information that happens to be in this generator spec. Just go back here. This generator spec has references to objects and attributes and stuff like that. So I just scan through this object, and I set up a bunch of variables, and then I go into these templates, and I say I'm going to generate, I don't know, an enum header. So this is the code for an enum header, and I just basically substitute in all the variables. There's a little bit of intelligence going on as well, but that's how it's done. So if you decide you want to change the way it's working, or you need to include a different namespace or anything like that, you have the ability to go and modify it without having to totally understand what the SQL generator is doing. I'm not going to get into the details of how the SQL generator works, so we'll just leave it at that. Anyway, so everything I'm going to be doing on this model today is going to be done in this example model. So here we have the example model.simp, and basically I need to create this model. It already exists, but I'm going to create a new version of it. So I'm just going to grab the name here, and I'm going to go into the software ideas modeler, which looks like this. I already have this model open. I'm going to start it again. I'm going to file new, and I'm going to call it example model, and me, and this is my sample. Good enough. And you can set up a password and all that kind of stuff, and then you click save. So here's the example model, but I'm just gonna overwrite it. So I don't care anymore. File is not accessible for write. Wonder why that is. Oh, I know why. I have it open over here. Let's see now. Let me just close this all off. No, close this. And I'll start up the ideas modeler again. There we go. So new. Save it again to example model and save. Yes. Okay, so now the model's been saved away. There's nothing in the model, so you can sort of see over here that that's what's going on. And over on the side, you have the ability to enter in some class diagrams. So I'm just going to click a class diagram, and it pops me open into the class diagram editor. The things that you'll need for modeling are classes, enumerations, associations, and generalizations. So there's a whole bunch of other things that you could possibly represent in this tool and generate code from. If you want to expand the modeler to take advantage of that, go right ahead. I'm only providing the mechanism that I'm going to show you today. So to create a class, you go in and you grab the class from here and you just drag and drop onto the palette. And I'm going to create a class here called Planet. And we're going to write something like a planet simulator kind of thing. So this is the name of my planet, and if I right-click the planet and select Properties, it'll bring me into a Properties panel, which gives me a whole bunch of information about the item. I can make the class abstract, but I'm not going to do that in this case. The main tabs that we'll be dealing with are General, Attributes, and Documentation and Tagged Values. So I'm going to jump actually straight into tagged values and talk about the fact that every class that you create inside of Sim has to have a tagged value called SubType. So SubType, and you give it a name. So once you assign the SubType, it really can't change throughout the life of your game unless you're going to replace your databases. So here's my subtype, and when I click OK, you'll notice it doesn't appear here. So the next thing you have to do is right-click the diagram, so this blue area, and select Diagram Properties and Show Parts. So I'm going to show tagged values. So when I grab this and make it a little bit larger, you'll see the subtype planet appear. So this just indicates that there's a subtype or a tag value called subtype. And what I use the subtype for is to differentiate between subtypes of the same type of object. So when you have an inheritance hierarchy, I need to be able to differentiate between them all when I'm loading objects out of the database. So the first thing I'm going to do is I'm going to add a documentation, and it pops up in this documentation window, and I'll say information about a planet. And I'm also going to add an attribute. So go back into Properties, go into Attributes, and click Add here, and I'm going to say Name. You should really edit all of your attributes through this attribute editor. There is a way to sort of edit inside your class, but sometimes it messes up. And it doesn't mess up because there's something wrong with the software. It's more I'm expecting attributes in a particular way, and when you edit up in here, it kind of messes up how the attributes look. So I'm going to make this a string 50 field. If you don't specify a length with square brackets, the default is 255 characters. You could make the name like 15,000 characters, like that. SQLite will support quite literally any sized a string up to, I think, 1 billion characters or something like that. So I'm going to make the name here 50. And the other thing I need to do is set the documentation. So I'm going to say the name of the planet. Good enough. So I've created a property called name. I've created some documentation for it. I've created some documentation for the property, and I'm done. So I'm going to go ahead and initially generate this class. So to do that, I go into Unity, and I make sure that my example model is specified. I go into the console and clear off all the information that's there, and I click Generate Code. So this thing generated successfully, which is a little bit surprising because I was expecting errors, but we'll see what it has to say. Generated the factory. Oh, I know why. So go back into here. So it only generated one of 3 files that I was expecting, and the reason why I did that is because I forgot to save this. So you notice in the top bar here there says example model star. The star means it's been changed, but it hasn't been saved. So let me save it, and then I'll go back into Unity, and I'll generate code. Still successful. So this will be the second generation. So it created a table, it created a domain, and it created a factory for 260 lines. And if you haven't seen the other video, you might wonder why there's 260 lines, but I justify why there's lots of lines in the application, because there's lots of comments and stuff. So let's go into the Notepad++, and you'll notice now that there's a domain, data domain object called planet. There'll be in here there'll be a planet table. There it is, and there'll be in here something called factories. So let's go into the tables component, and I'm going to open this up, and this is what it generated for me. So I have a warning at the top saying this is a partial class that's going to get generated over and over again, so please don't make any modifications to that. If you want to create your own behavior, basically you create another file in your assets, give the namespace the same as this one, so assets.data.tables, and you specify it as a partial class, table name with the same inheritance. And what happens is when you compile it, it will take your custom code with this generated piece of code and it will consolidate it into a single object that you're working with. For other thing you should notice is there's a comments in here. So remember I put in, this is information about a planet in the documentation. Every place that I can generate comments, I'll generate comments. So I try to generate code the way I'd write the code, because I want the code that I create maintainable. So if for some reason the tool becomes unusable, or you go in a different direction, or whatever the reason, the code that gets created is actually usable and you can understand what's going on. So there's comments everywhere, there's blank lines to make it readable, and so on. So basically what's in the planet table is a reference to base table. So it has a whole bunch of fields. It has to have an OID and it has to have some other things going on in it. There's a default constructor, which generally doesn't do anything. There's a method here that allows you to create a table. So after you construct your database file, you call something in the factories, which we'll call these create table objects. And there are by default two methods that get generated. One that gets everything by an object identifier, and one that gets all the objects in the database for that particular type. So if I go into the data domain and look at planet, here's the planet default. There's a default subtype for a planet. So if you decide to have subtypes of planets, there'll be other subtypes, and I use the subtype here to differentiate between one subtype and another. So if you go into the model and you change your subtypes and you have an existing database, the system won't know how to load in that object, and essentially it will ignore that data as essentially unusable data. So you could actually have, we'll say, child or orphan data inside your database if you do that. So not a good plan. Here's a property. So the way the properties work is there's a background protected element. So if you were to use subclassing, you'd be able to have access to this object. Normally you want to just use the public version of the name to do your manipulations and do your testing on. It tests the value, so if the value is changing, then it updates the value and sets the dirty flag. Dirty flag is used for unit of work, and if you don't know what that is, see the other video. There's a bunch of constructors, but when you're constructing a planet, you specify an OID. So if you're creating an object from scratch, you specify this as 0, and you give it whatever the name is. And the other thing you need to be careful about is just setting the dirty flags. So you should use the constructor to create something, or the potential is you might accidentally create something that's dirty when it's not really supposed to be dirty. Anyway, so the planet comes along. There's validation logic here. So this is how you save your objects to the database. First thing it goes through is validation results. So we'll call the validate method. Right now the validate method is basically an empty class. It generates one of these validation result messages and then returns. So it doesn't actually issue any error messages. But if you put in your own override of this method and issue an error, then you can prevent your saves from actually taking place. One word of warning is Unity, if you issue multiple errors out of this validation logic, which you can, I'm not saying you can't, your interface will have to be able to present those errors in some way A lot of coders will create only one error, so they only have to support one error. But if you have multiple errors, that's one trade-off you have to have. So if there's no errors here, it goes in, constructs a table object, copies in all the attributes, and then calls the repository to save it away. One of the things that the repository will do is if you're doing an insert, the insert process will identify a new object identifier and it will assign it to this OID. So you don't have to worry about, I created OID 15. You don't have to try and figure out what that new OID is. It'll be automatically updated in the instance. If the repository is unsuccessful in saving, it will set the result to false. And in this case, this if statement will basically say if it didn't work, write out an error. So you'll get an error in some way or another, whether it's a validation message or something with the database didn't work. And then here's the two default fields that default methods that got created. One to find object by the OID and one to find all the objects. In one case, it's returning a single planet instance. In the other case, it's returning a list. And the way it works, I'll just use the planet all here, is in the table, there is a get all, and it's going to return a bunch of table instances. And in order to convert these into planet instances, you need a factory to basically convert these table instances into planet instances. And what's happening is you go into the environment, you initialize the environment, and you basically tell the factory, okay, if you got planet table instances, you use this method to transform them into planets. If you have some other type, it'll explain how to do that. So that's how this transformation takes place. So the last one to go through quickly is the factories. So this is your initialization. So when you come into your environment for the first time and are using, you need to initialize the environment to tell the system which methods to use to get individual objects given an OID, and which objects to use to actually convert your planet tables into planet instances. And so that's actually coded again automatically below, and I'll explain that in a second. If you're making this table, because this is, if you're making a brand new database, there'll be a whole bunch of entries here for all the tables that are in the system. So you make one call to make database and we'll call off all the create table instances. And this is the read factory. So this read factory here is this read factory here. And what it does is it takes rows out of the database, which are just these iRow type things. And just based on the way in which you describe it, you can safely cast. So that's what it's doing. It's safely casting iRow, this row coming in as a planet table into here, and then I evaluate the subtype, and then based on the subtype I know which constructor to use. So that's the basic functionality of the one class. So let's move on and talk about some of the other capabilities. So I'm going to clear this so I don't have to do it later. All right, so one of the features that you do have is if you go into properties here and into an actual property and edit it, is stereotypes. So by default, there's a whole bunch of different stereotypes. If you wanted to add a new stereotype, if it's not here, you can add custom. So if I wanted to add custom, find and click stereotype, and then when I click OK, it will add it to this list for me. In this case, I'm not going to worry about it because it's already there, but I'm going to include the find stereotype. So I did that, and I click OK, and you'll notice this particular attribute has been marked with a stereotype called find. I'm going to save this project away. I'm going to go back and generate inspector, generate code, make sure there's no errors, there are none, and then I'm going to go back into here. So I have the system automatically update, so there's no changes to the factories, but in the tables there'll be changes. Specifically what it does is it creates a find method for planet. So this is the find method that it generated. So what it does is it goes to the repository, gets a temporary database connection, goes to the table and says, so I pass in the name, it comes in here and says find where name equals name. And so it'll go out to the table and find that row. It's important to note again that the system is intelligent in that it won't do a select star just with this statement. What it does is it actually generates based on this entire clause. So if there happens to be 1,000 planets in the database and you execute this clause, you'll only get one row back from this table. It actually goes out to the database, selects the one row, and then passes it back. It doesn't select star from that table, then run a memory loop against all the rows to find the one row, because that's data very inefficient. So it's an intelligent way of doing this select statement, or sorry, doing this this find. And again, it's all with SQL or LINQ rather. So basically, it's generated this extra method for me called find by name. And if I go into my planet, you'll notice there's a new method here as well. So we'll make it'll call the planet table find by name, and you'll find here's the factory, here's a table, and it's loaded in by name. So that's the find method. If I go back into the modeler, there's a couple of other attributes you can add. So let me just go ahead and do that. And I'm going to talk about them. I'm not going to add them in. I'll maybe do that later. So you can add an index. Actually, maybe I should add an index. I'm going to add an index. Save it away. Quickly compile the thing. Clear. Generate. Done. No errors. Good. Let's go back into my code. And there'll be no changes to the planet. There'll be no changes to the factory, but there'll be a really subtle change to the planet table. And that will be the addition of this attribute called indexed. So basically what it will do is when the table is created, a create index will be done against the name field. Now you should be careful not to index all of the table or all of the columns unless you're searching by them. And if you have fewer than usually about 50 to 100 rows, it's actually more efficient on the software, especially in the database, to just do a full table scan. Let the database do a full table scan. And the reason for that is because most databases store rows in clusters of rows rather than individual rows inside the file. And so when it's actually loading, it's going to load in a cluster, and that cluster might have 20, 30, 40, 50, 100 rows in it, depending on how big the cluster is and how it's configured for the database. So if you're doing, let's suppose it's this particular table has 4K blocks in it, it's going to load 4K in and search through all those rows, and then load in another 4K and search through all those rows. And that may seem like a lot of data, but if you're using an index, for example, you'd have to go load the index, scan through the index, and then load the cluster anyway. So all that extra I/O, it's actually faster to just load the clusters in. So that's the reason. So that's all that index did. But it's really nice, right? Because now you can say, I need a find and I need an index, and it's done. You don't have to worry about it. Yeah, so that's planet. So I'm going to create another class here called SETTLMENT. I'm going to create some documentation. I can say so that's my documentation for my class. Go into properties, go down to the end here and set a tag value, SubType. Tag value will be SETTLMENT. Good. And go back here and create an attribute. Add name. Good. And actually, I'm going to add a stereotype to this guy as well. So I'm going to go back in here and add a find. So what I've done is I've created a class called SETTLMENT, has a subtype of settlement. I've created another name field, length of 50, and created a find on it. So I can generate this, and let me do that. Let's see. Go to Unity, clear, generate code. Awesome. No errors. Awesome. And then we'll go into here. So now you'll see there's a planet table and there's a settlement table. It'll look very similar to the other settlement table, or sorry, the other table that was there. There's a find by name. In the data domain, there'll be a settlement instance as well. And it'll look very similar to what we've gone through before, so I'm not going to go through that detail. And the utility area will have now a new read factory that basically has the read factory for the planet and one for the settlement. The other change that you'll notice is now that we're dealing with two different tables, there'll be two tables in here. So when you create a new object, you just say make the database. And these two have been updated as well to identify the object identifier, find method, and the read factory for the other piece. But the reason I added settlement is I want to talk about associations. So an association basically means that two objects are related to each other in some way. I only support one-to-many relationships. If you need a many-to-many, you basically have to create an object in the middle that is the resolution between the two. And I don't support one-to-one relationships. So what you do, actually, let me go back. So to create an association between two classes, you basically click association, and you notice as I've dragged the mouse over, the screen changes to a little blue area. And if I move further away from the center, it jumps to the edge. So what that basically means is if I hold down the left-hand mouse button and click here, it'll link or connect the association to the edge of the box or the edge of the class. If I'm doing it here, it's to the center. So if I drag, you'll notice there's now a line running out, and I can drag to the edge of settlement, or I can drag to the center. So in this case, it's dragged to the center of the object, and it draws a line between the two. So we need to go into this line and do some things. So I'm going to double click it, or I can also right click it and select properties. It'll pop open a properties dialog, and the two tabs that we're interested in maintaining here is the relationship and the documentation. So I'm just going to say for the documentation, I am identifies the settlements on a planet. And then in the relationship, I need to fill out the roles. So the roles are used in a very important way inside of the model. So for you have to think about it in reverse. So I'm just going to fill this out, and then I'll explain what's going on. So the planet and settlements. And the other thing you should do is for your end roles, you should specify 0 to 0 ... star, which basically means that a planet will have 0 to many settlements. So it pops up like this, and I'll just drag this around. All right. So I added a role called the planet, a role called settlements, and I added this for notation purposes. I don't take advantage of this at all. It's for your benefit. So the way this works is when I generate, actually let me save this away. When I generate, the settlement will get a new attribute called the planet, and planet will get a new attribute called settlements. And the way it works is the system will now provide a lazy loaded association between these two instances. So for the planet, basically the settlements will be all the settlements that are in the planet, and for the settlement, the planet object will give you reference to the original planet instance and allows you to have access to it. So I save it away, but I'm gonna do it anyway. Again, go into Unity, go into the inspector, generate the code, successfully generated. Looks good to me. There were no new tables or domains or anything else created, because this is all internal. I'll go into the domain. So the factories will be untouched, but if I go into the planet, there will be now a new instance added called settlements. So this is a lazy loaded children. It's a generic with a whole bunch of funky attributes on it. But basically what this does is it will create a new attribute called settlements. You can refer to it directly, and you can say settlements dot or square bracket 0 and square bracket, and you can get the first settlement in the list. And it's lazy loaded. So if I go back to this model for a second, what lazy loading does is if you're sitting on the planet, you load a planet into memory, and then you decide, hey, I need to know what all the settlements are on that planet. You can say my planet dot settlements, and as soon as you make reference to dot settlements, the system will say, hey, have I loaded settlements in for this planet? If the answer is no, what happens is that settlement loads up all the settlements for the planet and then returns them back. So it looks like it's always in memory. So it's this lazy loading of data. And similarly, if you're sitting in the settlement and you want to make reference to the planet, you just say the planet.name, and it'll go out to the database, grab the planet, and load it in. So you don't have to worry about how to load all this objects. You just make reference to it. Now, before I get too far along, there is a trade-off with lazy loading that you need to be made aware of. If the number of instances that you're pulling back is relatively small, like maybe 20 to 30, it's not such a big deal. But if there are thousands of instances here, sometimes it's more efficient to actually just pull all the settlements of interest rather than doing this lazy load. Because the lazy load is going to load all of them, but 1,000 instances is going to be far too much information for the average person to consume. So basically you make it easier for them to actually load this data. And so that's what you're trying to do, is you try and load it in chunks that's easy for the user to maintain. Now, again, it totally depends on your application, on your game, as to how you want to do it, but that's the trade-off. It's sometimes more efficient to actually go to the settlements and get the things that you want than it is to actually use the lazy loading mechanism. So you have both choices in this game, so you're not constrained by one. Anyways, going back to the code here, so now we have this lazy load children, and as soon as you make reference to the settlements, if it's not loaded in memory, this object here will load it in for you. On the settlement side of the world, there'll be a new object thing here called the planet. And what the planet does is it says, is the value there? If not, it does the assignments, and it basically wraps the value of what this thing is returning back into your environment. So there's this internal logic, and it will automatically load stuff for you automatically. So you just say settlement.theplanet.name, and you'll get the name of the object, whether or not, the name of the planet, whether or not the planet was loaded prior to you making the call. And the other sort of change is in the constructor, the planetoid may get passed in from the database, and this is how you construct the new master. So you say lazy load master planet table and give it in the name. So this is all it needs to initialize it. In factories, in planets, under the constructor, the child will get assigned this lazy loading. It's assigned directly to the object. There's no dirty flag, because assigning new instances to settlements isn't going to make any difference to whether or not the planet is considered dirty, because these things are actually associated with, when you assign it to when settlements get assigned, it's the settlements become dirty because it's the foreign key relationship that matters. So that's why it's not an underscore in this case. And there's one thing in the documentation to keep aware of, is sometimes you need to be made aware of when instances are added to settlements. So in your code, you may want to add a event on the settlements. There's an event called after add. So after an instance has been added or inserted into this list, you can be notified of that insert and do something special with it. In another application, before I converted it to Unity, it was used to maintain a count so that there would be an order in which things occurred. And there's nothing in the factories, so nothing new in there. So let's go back to the model, and this time I'm going to add another class. I'm going to call this class town, and I'm going to go in here and say attribute, call it the mayor name, 50. Tag values, not going to have any. Good. And I'm going to make town a subtype of settlement. So to do that, you go into a generalization. And like the association before, you just drag the generalization from the from the subtype to the supertype. So I created this association. There's no documentation on this. It's just a reference to it. So now what we should see is single table inheritance actually being implemented. So I'm just going to highlight these two for a second, and well, maybe not. So basically what happens is now the town and mayor name are now going to be stored in the same table as settlement. And to differentiate between the two, I use the subtype, and oops, I forgot my subtype, so let me go back and I'll re-explain what I was trying to explain there. All right, so what it does is it goes in here, and when it's loading instances out of the database, it's going to either be settlements or towns. And for towns, you'll get a mayor name, and for just settlements, it'll be just whatever the name of the settlement happens to be. And since a town is a type of settlement, the name that's used for the settlement will be the same that's used for the town's name. This is single table inheritance, so basically all of this data is stored in the same table, which means after we do the generate, what you'll get is two tables in the table layer and three classes in the domain layer. So one class, and one class, and then for the table layer, it's this class, or sorry, this table, which includes these two objects or object classes and this one. So hopefully I explained that all right. So go back into Unity, clear this, generate the code, mayor name. So I didn't include documentation on the mayor name. So let me go back and do that. So properties, edit, documentation. Save that away. Go back into Unity. Generate. All lovely and stuff. So that's what happened. So there are two tables created, one for planet and one for settlement, and three domain objects created, one for planet, one for settlement, and one for town. So let's see what that looks like in code. I'm going to just close all these. So in factories, what you get are this hasn't changed because we're only dealing with two tables. So there's only going to be two entries here. Make tables the same. Read planets the same. But now under settlements, there's now an extra row in here to differentiate between towns and settlements. So here's the settlement subtype, and here's the town subtype. If you look at the settlement subtype, which is the base class, You have the oid, the name, and the planetoid, which is the foreign key relationship to the planet. And in this one, you have the oid, name, planet ID, and now the mayor name, because that's the extra field that's in there. If you look inside the table for a settlement, you'll see that there's now a attribute that's used to maintain the mayor name. So it won't be maintained for settlements, but it will be set up for the town. If I go into the domain, and you'll notice now there's two domain pieces. So if I go into the settlement, the default here is to inherit from a class called base class, which has all the basic functionality in there. If I look at town, you'll see that it inherits from settlement. So here's the town, and it inherits from settlement. So here it has the name, and when I construct the object, it will have the name, planetoid, and the mayor name. So it initializes all this stuff for us. Save is pretty similar. It's going to have the oid, subtype, name, planetoid, and the mayor name, and looks very much the same. Settlement will have all this same stuff in here as before. So that's what the general inheritance does. So I'm going to do a couple of more things, and I'm going to generate again. So I'm going to create one more thing here. I'm going to call it a city. Set the subtype. And set the documentation. All right, I'm going to make this a generalization of town. And I'm going to create another class called a district. Properties, attributes, string 50. I'm going to make this that. Good. Give it a name for the district. So, oops. Grab that and put it in here. Go back to the properties. Change this to the correct thing, which is the name of the district. Period. Click OK, and I'm going to create an association to here. Now, I realize that this is, I'll say a mistake. I'm going to move the association a little bit later. But eventually what I want to do is I want to move this association to settlements. But I just want to show you what you can do with this. So the district, I'm initially going to call this cities. A multiplicity of 1, 2, or 0 to many. It's around here. All right, so we got that. That's named. I don't have a subtype, so good one here. Awesome. So what I've done is I've created another subtype of settlement, which is also a subtype of town, and I've created an association to city that are districts. Later on, I'm going to move this association over to here, but I just wanted to show you some additional capabilities that you can do. So I'll save this object away, and hopefully I'll have no errors. So clear this and say generate. It was successful. I'll just look and make sure. Yep, there's a whole bunch of stuff that was generated, no errors. So if I go into here, I'll just close these guys off again. I'll start off by looking at the factories. So now there's a whole bunch more stuff in here. There's one row for each of the tables. So here's my district table. Here's the read factory for the district. There's now 3 tables that get constructed. Planet is the same. The settlement will now have a new entry for city. And like this one, it's the OID name, planetoid, and the mirror name. And here, in this case, we have the motto and also the district name. And I'll hold that for a second, and then there's a district that's being initialized. So I'm going to go into tables, and I'm going to go into the settlement table. So now the settlement table contains all this information. So here's all the original information for the settlement, the original OID and the name. Here's the name for the town, and then here's the information for the city. So here's all the identifiers, the district, and here's the motto. So this is what's constructed in the table, and it's in the factory that I differentiate between which attributes I'm going to use for my constructors. And then, sorry, back into the factory. So that's how it differentiates between the 3 types. And remember where this district got assigned, because it's going to get moved up here in a second. And then I go into my data domain, and once more I have a city. And here's the city. It has the load master, the district, and if I go into the district, it'll be a child to cities. So here's the city, here's the district, and this is where I get the city information loaded in from. And since it's the settlements table, it needs to do a little bit of intelligent work to actually get the right pieces out. And that's how that works. Okay, so close this all off. And I'm going to go into here. And like I say, grab this guy and make it settlement. So now I have to change this name from cities. I'm just going to go into the world and do it. Change this to settlements. And that's it. Do the save. Go back into Unity. So you can see the back and forth iteration that's going on here. So I've generated it lots of times. It was successful. Look at the errors. No errors. Excellent. So I go back into here. The tables are basically in here. So if I go into the settlement table, everything is the same as before, but the major difference is now the district OID is associated with the settlement. It used to be further down with the city. Now it's been moved up. Now in itself won't make a difference. It's when we look at the data domain that you'll see the difference. So before, the district was associated with the city, but if I look through the city code here, you'll see nothing in here that tells me it was, well, other than the initial load here, but there's nothing in here that says it was. And like even the district's been moved up the list. It's in the settlement now where we see the district being defined. And now everything will get lazy loaded because these are all the things that are associated to it. All right, so that's how you kind of do that kind of work. And there's one more piece I need to show you, and that's enumerations. So I'm going to create an enumeration. So what you do is you grab an enumeration object and drag it over here. And I'm going to say town types. I'm going to put it over here just to be different. So what town types do is it allows me to create integer values with known specific types. So I don't have to put in an if statement. If it's 1, then it's going to be this value. If it's 2, I can actually use an actual name for something. So to make town types work, I have to go into the town, and I'll set the attribute. I'll create an attribute called the type of town. Actually, yeah, like that. It's going to be type of integer, and the documentation will read historical or current state of the town. Okay. And in here, I'm going to have I'm going to go into properties. Since this enumeration, the attributes change to items. So add an item here. Actually, I can do it in here. So I'll just say current, or actually populated. It has a value of 11. Oops, sorry about that. Populated will be historical. Be 21. Abandoned will be 25, and about destroyed be 31. So those are the values that I want these things to mean. What you create is entirely up to you. One thing I forgot to do actually is let me go back into here. So I can jump into there by clicking quickly. So if I go into editor, I can say with peons. Okay, and this is and destroyed. Okay. So those are the different town types. Now, in order to make the enumeration work, you draw an association from the enumeration to the object where it's going to be enumerated. And there's a special relationship that you create. So right here it says the name of the town, int, has to be essentially the starting role of this association. That's what I look for in the model. So I'm just basically going to take this name and go into here, oops, to here, and the starting role has to be the same name as the attribute that's inside the this object here. So that's how it works. And so it's going to generate an enumeration. There'll be no table created for it because it's not really a table. It's just a way of representing stuff inside the domain. There'll be types of towns, which I don't have documentation for. So there'd be different types of towns. There's documentation on individual attributes. I don't care about the documentation on the line here, so I don't include it. And the other requirement is the type of town is the type of town. So that's the setup of enumerations. So I'll go back into Unity. I will clear and generate. Successful, yay. Oh, so it does complain. I don't know if it actually does anything with the comment. I might have to take that out of the actual generator. Anyway, so let's look at the code that was created. So now we have town and town types. So if we go into town and have a look, you'll now see that the type of town is a type of town types, and town types is an enumeration. So here's the enumeration with all the documentation and all the values that we had specified before, and inside the town, here's the town and the type of town. So what happens is when the object is constructed, it is cast into a town types when it's loaded in. So here's the town, and it is cast into that value. So now whenever we make reference of type of town, we have to now use the enumeration. So it's always restricted to those values. When we save it away, we cast this attribute into an integer. So here's that reference. So inside the table, there'll be the type of town, and it's an integer, and this gets cast from the enumeration as an integer back into this piece. So if I go into the town itself on the table and go into the settlement type, there will be a type of town, and it's an integer. So that's the way it works. And that's it. So what I've done is I've demonstrated that you can create classes, and I've given a whole bunch of examples of classes. I've shown that you can create enumerations. I've shown you how to use single table inheritance. I've shown you that the relationships, the associations that occur specifically to the class that's being used, not to the base class. So when we created districts for the first time, we created under city, and you saw that only the city had the district, but when we moved it over here, that district is now common to all these subtypes. I've shown how you can basically name attributes, use of the multiplicity, and yeah, that's it. So hopefully this video was informative, and I really hope that you try out my generator and SQL tool, because I really do think that, you know, like if I go back into Unity and I look at the console, in that short amount of time we've generated 1,200 lines of code, and of course I'm explaining this as I go along. Can you imagine how long it would take you to craft 1,200 lines of working code and interact with the database? Like hopefully I've demonstrated that you don't actually have to worry about writing any SQL statements anymore. Anyway, so that's the video. Hope you had fun, and like I say, if you need more information, you want to go to games.lnsky.info. All right, thank you for listening.